Okay, so on to exercise 1.2, which asks us to prove that there is no set X such that the power set is a subset. How are we going to do that? Well, a natural guess is to go by contradiction, so that's in fact what I will do. Before moving on, I'll just point out that I use this horseshoe notation for the subset, and this also permits equality, as the author does. This is kind of an older school notation that A subset of B is consistent with A equal to B. So in modern, more popular modern notation, to say that you would have to have a bar underneath the horseshoe, but in this book he doesn't use that notation. He permits this to potentially allow equality, so I'll do the same. Okay, here is the contradiction. We suppose that there does exist a set such that its power set is a subset, and then I can produce a kind of Russellian contradiction off of that, because the main thing that was stopping us from producing a Russellian contradiction without this kind of an assumption is that there's no parent set to pick from. So you can't say, take the set of all sets such that X does not contain itself, because you don't have this universe of sets over which you get to quantify freely. But if I have this assumption, it does produce a large enough universe to quantify over that I can actually produce a Russellian paradox. So here I have it. Define this set Y, which is the set of all elements of the power set, that is to say the set of all subsets of X. This gives me a parent universe to select from. Take all of those which do not contain themselves. Now, just to kind of reinforce the point, Y here is a subset of the power set, right? Because after all, I'm just picking elements out of the power set and forming a set out of them. The power set we assumed was a subset of X. That makes Y a subset of X. Well, if Y is a subset of X, that just means that it could be one of these little A's, because, right, each one of these little A's, being an element of the power set, therefore makes it a subset of X. So Y itself could be an element of the power set, and that's what makes it intelligible to ask whether or not Y is an element of itself. Of course, if you then go ahead and ask that question in each direction, you get the usual contradiction. Since every avenue leads to a contradiction, then the case has been proved.